This question is to solve a statistical problem involving a veterinarian study of aggression in two groups of shelter dogs. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Thank you so much. A veterinarian is studying aggression in two groups of 50 shelter dogs. One group received daily exercise and social interaction. The other group was kept in isolated kennels. In the socialized group, 10 dogs showed signs of aggression. In the isolated group, 22 dogs showed aggression. Construct a 90% confidence interval for the true difference in aggression rates between the two groups. Then interpret the result in the context of the problem. First step is to recognize the problem type and identify values. This is a two-proportion confidence interval problem. The goal is to estimate the difference in aggression rates between two independent groups of dogs. Let P1 hat represent the observed aggression rate in the socialized group. This is 10 divided by 50, which simplifies to 1/5. Let P2 hat represent the aggression rate in the isolated group. This is 22 divided by 50, which simplifies to 11/25. We want to estimate the difference between P2 and P1, the true aggression proportions, using a confidence interval. Before continuing, we need to check if both samples are large enough for this method. That means both groups need at least 5 aggressive dogs and at least 5 non-aggressive dogs. For group 1, 1/5 of 50 equals 10, and the remaining 40 dogs were not aggressive. Both are at least 5. For group 2, 11/25 of 50 equals 22, and the rest, which is 28 dogs, were not aggressive. Again, both are at least 5. So, the conditions are met for using a two-proportion z interval. Next step is to apply the confidence interval formula. We are using a 90% confidence level, so the critical value z star is 1.645. Now we calculate the difference between P2 hat and P1 hat. That's 11/25 minus 1/5. 1/5 is equivalent to 5/25. So the difference is 6/25. Next, we calculate the margin of error. The formula involves the square root of two parts added together. The first part is 1/5 times 4/5 divided by 50. The second part is 11/25 times 14/25, also divided by 50. When we compute both parts and add them up, we get a value that is approximately 0.0837. Taking the square root of this gives approximately 0.289. Multiplying by the z value of 1.645 gives a margin of error of about 0.476. Now take the difference in proportions, which was 6/25, or 0.24, and add and subtract the margin of error.